Yeah. Well, it's on the hour. So I think we start. Good afternoon, everybody, and welcome to this Arrowhead Ecosystem Seminar, webinar. My name is Jochen Henisch, and I'm your moderator today. First of all, yeah, this session is being recorded. So if you do not agree to being recorded, then I'm afraid you will need to leave. Else, as a little introduction. So the mission of the Arrowhead ecosystem is to support industries, government, and other organizations who want to move their operations into the next generation of IT solutions. So the purpose is to increase the efficiency and sustainability of your organization and gain a competitive edge that allows you to quickly adapt to future opportunities, business opportunities, without the inflexibility of a vendor lock-in. So without that. The Eclipse Arrowhead ecosystem provides local support for Arrowhead in your business vertical. And our current community of users, Arrowhead users and developers, includes many domains, among them smart city mobility, Internet of Things, Industry 4.0, energy, semiconductor, consumer industry, as well as aeronautics, space, and defense. And all of those are present today, and we'll give a short presentation. So the current community of this ecosystem spans the European continent in the first place, but with partners able to provide support also in Europe, the US, and otherwhere. So much as a little introduction to the topic. Some meeting rules, recording I mentioned. The presentations today will be distributed after the webinar. There will be a question session at 3:45, so at the end, after all presentations have been given. And feel free to ask questions in the chat in the meantime. So we'll either answer them then at the end, or if we don't manage to get overall in time, then we will answer them by mail. For those who are on the call, please mute your sound and also mute the video unless you are speaking. And presenters, please stick to your 15 minutes slots. I will break in probably when you're getting close to it or when you're below it. Well, after this short introduction, I hand over to Gaël Blondel, who is the Managing Director of the Eclipse Foundation Europe and the Vice President for the Ecosystem Development and a strong supporter of the development of this ecosystem here for Arrowhead. So Gaël, you're welcome, and please, the stage or the screen is yours for the next 15 minutes.
Yeah, can you make me a presenter so I can share my screen?
That's not in my power, but I hope Javor can do that. Javor, do that?
Sharing of so it's not to just it's not
yeah. Whose name whom should I make presenter?
Gaël.
Sorry.
Gaël Blondel.
And it'll be actually interesting to see your
Yes.
gone through it all.
Now stage is yours.
That works.
Yes.
Do you see it?
It works. Thank you.
Okay. So let me remove that. Okay. Yes. Okay. So, well, good afternoon, everybody. Thanks for the invitation. I think that the topic of open source to transfer technology from research to the industry is a very important topic. Also, the topic of building business ecosystems on top of open source is also a very important topic for which we are fully committed to help at the Eclipse Foundation. And so thanks for inviting me for a few minutes to give you my perspective on this. Before we start, I just have 2 slides about what we do at the Eclipse Foundation. So we are what we call an umbrella open source organization. We have 400 projects which cover all kinds of topics. So yes, that includes development tools, cloud, IoT, edge, automotive, AI, Industry 4.0, and we recently finalized our move to Europe. So we are a European-based organization since early 2021, and we are the largest open source foundation in Europe, fully operating under European law and hosting code on our GitLab servers in Europe. Still, I think that's important to mention from the beginning that open source is global, and we are a global organization. We want to stay a global organization, but serving the ecosystem as the open source foundation of choice for strategic open source projects in Europe. Yeah, we have been involved in tools, IoT and edge computing, automotive, cloud native Java for more than 10 years. And since we moved to Europe, we are investing strategically on artificial intelligence, cloud, and also operating systems. To finish on this short introduction, I would like to give a highlight to our strategic members. So you can see on this slide, yeah. You can see on this slide that we have a majority of European organizations in our strategic members. And of course, I would say that we also have the usual suspects of software technologies. That includes IBM, Microsoft, Oracle, Red Hat, Huawei, etc. So they are participating in every open source organization. But what I find very interesting from our perspective today is that we have members like Bosch and Daimler, for example, who are, those industry players who are now adopting open source to set up strategic collaborations, and I think that's really an important point for our meeting today. So let's start about maybe my position statement on the topic for today. So in 2011, Mark Andreessen published his famous article saying that software is eating the world in all domains. And more recently, lots of people claim that open source is eating the world because everybody is using open source on different angles, and I will come back to that, but there are several approaches of using open source. There is a commoditization approach, and there is the innovation approach. But what is open source? So that's a flavor of intellectual property management at the beginning. Open source is really this idea that the authors of software publish their intellectual property under a well-known license that gives some rights to the users to use, study, change, and redistribute the software. So that's important because sometimes we think that open source is all about building communities. And yes, communities are very important in open source, but it's important to understand that it's one way of managing intellectual property. And it's one way of managing intellectual property that gives several good properties to the users. But there are several ways of doing open source. So one approach of doing open source is you push your code to GitHub, for example, or another collaboration platform. That's easy. That's the easiest way to start. And you just have to decide where to put the software and also what kind of license you want to use. But there is no complex IP management process, etc. And to some extent, that means that there's also no guarantee that this code that is hosted on a collaboration platform can safely be reused in an industrial setup. Another way of doing open source is famous. It's what we call single vendor open source. That's when a company, one single company, publishes a part of their product in open source and ensures that they keep all the intellectual property to retain complete control of the project. That can be fine. But we also know that in the recent years, we observed several times when this approach turned to become to move from open source to proprietary software, which can be an issue. And there is the open source foundation way. And the role of an open source foundation like the Eclipse Foundation is really to ensure sustainability and vendor neutrality. And that comes from a set of services. For example, we provide our own services in terms of intellectual property management and license checking, etc. But also we have processes to ensure predictability of the development process, and we have a strong governance that ensures vendor neutrality, because vendor neutrality is exactly what makes the software project sustainable. So this slide is important in my opinion. That's really about Eclipse Arrowhead is a project that is hosted in a setup that enables sustainable vendor neutral open collaboration. Just one word about open source as a research catalyst. We have experienced in the past that open source is a good setup to help disseminate results from research projects. Basically, we can catalyze a collaboration between researchers, between SMEs, and between large organizations around an open source project. And again, one of the advantages is that everybody understands the rights and duties associated to a well-known open source license like Apache or Eclipse Public License. And so that really makes collaboration easy because everybody understands the rules. And this is really a good way to start building assets and sharing assets. One important aspect is that one of the advantage of mixing research projects with open source is that you start with the initial community of project partners, which are good candidates to collaborate on the project. And I think that's what we observe today in the project. I will skip this one. Another aspect is that we think that it should be possible to collaborate on open source platforms, even between competitors, and to build products on top of the platform. And so the platform is open source, but enables the creation of a product ecosystem. And that's so to be clear, all our legal setup, governance setup, etc., has been designed to enable this kind of collaboration. So to conclude, I would like to go through a few takeaways. First one is, in the last 20 years, open source changed in nature. When I started doing open source in 2003, 2004, it was really in this idea of commoditization. We wanted to use Linux operating system to install databases on cheaper hardware. And so that was, I would say, the decade of the years 200,000 to 210 was about commoditization. But for the last 10 years, it's really about innovation. Every innovation is starting from the beginning with a flavor of open source. That can be big data, cloud, AI, edge, and IoT. You need open source because you need to be scalable. And this, from my perspective, this is really an opportunity. But the opportunity will only materialize if the different stakeholders decide to use open source as a strategic enabler. That means moving from using open source to contributing to open source. And what we are talking about today is really to using open source as a catalyzer for leadership. So we can set up powerful collaborations in Europe that will help us project our technologies in open source to the rest of the world. And to some extent, that open source has already been there forever in IoT, in machine learning, AI, in cloud, and every distributed ledger technology is more or less open source. And I think that what you are doing in Arrowhead is really enabling open source for the industry 4.0. So that's still a place to conquer, and you are doing a good job in getting that started. The point is that there will be a platform like Kubernetes for the IoT and edge. And so the question is, who will do it? Where will it be hosted and started? And I think that's really an important opportunity for Europe. That's a very important opportunity for Europe because open source enables the free flow of technology internationally, and because we are in the middle of two blocks that are already using open source. So we have to use open source, and we have to use open source to show our leadership. And finally, I think I made it in 15 minutes. I was looking at the Eclipse Arrowhead project, and there is a metric that is very easy for us. It's the activity of a project. And I would like to say that, well, congratulations, you have a project that is very active. I mean, not all projects have more than 100 commits every month on average. And so that's a very good start. That means that you have a platform that is active with active contributors, and that's can be the foundation to build this ecosystem. So thanks for your attention, and well, have a good webinar.
Thank you so much, Gail. Yes, you were within 15 minutes. Well done. Then next on the list is Professor Yarkadel Singh, and you are from the University of Luleå, worker in Professor of Cyber Physical Systems, and among others, you are in the board of and vice president of the Inside Industry Association, and for now you're still leading and coordinating the Arrowhead Tools project. We're excited to hear what you want to say about the Arrowhead framework.
I just have to tweak some security things that some new WebEx things left with me. So
always something new. Okay. Javad is working on it. Yeah. Javad, what's going on?
He should restart, I think.
Did Jerke leave? Oh, Jerke's there. Okay.
now I'm here, and I will share my presentation. So here I am. I
Thank you.
will introduce the Eclipse Arrowhead technology and how we think it can be used as an architecture and an implementation platform for automation digitization. So I will start with sharing a video. So
what if you could save time and money while standing at the forefront of cutting-edge technology and fostering development of the next generation of green solutions, the automation and digital transformation?
this new WebEx is just sucking.
Started well, but it stopped.
What if you could save time and money while standing at the forefront of cutting-edge technology and fostering development of the next generation of green solutions? The automation and digital transformation, which is made possible with Eclipse Arrowhead, leads not only to competitiveness, but also to positive outcomes in terms of environmental impact and the use of resources. It's been shown that our software solutions lead to significant time savings. Processes that took a month now take a week, and what took a week now takes only hours, saving not only time but resources and money. And our tools can be applied in all kinds of industries, such as construction, mining, automotive, and manufacturing. We know that it's problematic when systems can't communicate with each other, which is why Eclipse Arrowhead was built. To allow your old systems to become part of an integrated solution, communicating seamlessly in cooperation with the latest internet technology to provide real-time data handling, data and system security, scalability of solutions, and standard-based digital twins. And you won't have to worry about backdoors because Eclipse Arrowhead's automation is based on the concept of self-contained local clouds, providing security from edge to cloud. Our vision is that with increased cooperation, everyone can have access to safe and dynamic digital systems. Our mission is to make working solutions easy and affordable for you to design and implement. This is why our new engineering procedures are tightly integrated with solution architecture, supported by integrated and efficient tool chains, model-based engineering, semi-automated solution generation, and more. Eclipse Arrowhead is an open source library where you can both borrow and share, allowing you to use a wide variety of applications that you can integrate as you like and transform into solutions for your needs, which allows you to choose the best of all systems available without being locked into one supplier. The open source library provides you the possibility to identify how your products or services can fully meet your customers' needs at competitive costs while helping them become standard compliant. So it's time to really look into where you can and should digitalize, to identify where in your organization it's in fact smartest to do so. Eclipse Arrowhead is created to assist industries and organizations no matter the size and scale of business. To sum it up, what you get with Eclipse Arrowhead is cost-effective solutions with high performance, security, interoperability, flexibility, real-time, scalability, standards, and more. So let's come together to accelerate the journey toward a greener, more digital future. Join our 80+ industrial and academic partners throughout Europe. Eclipse Arrowhead, powering Industry 4.0.
So what it's all about is to basically support Industry 4.0, as Gail was touching on, and integrating all the existing legacy technology with the new technology under the label of IT. So IT meets OT, operational technology. That's the direction of where Eclipse Arrowhead is moving. But what's the foundations for this? So they need to base on technology foundations to build upon. And the whole Eclipse Arrowhead architecture is based on what we call a microservice architecture previously. Also, this was discussed under the name of service-oriented architecture. It's based on a number of fundamentals like lookup, late binding, etc., and in particular interoperability. And I will just detail that very briefly and telling how we actually accommodate these things in the Eclipse Arrowhead architecture and platform. So the key architecture concepts, the 3 Ls, loose coupling, late binding, and lookup, they are supported by a service registry, an orchestration system, and a security system. And we call these 3 systems software modules mandatory. And this is the basics you need to actually start to build your solutions. And then we are thinking about how to scale things. Since each of these, if you take the 3 mandatory core systems, they, together with a few application systems, will constitute what we call local clouds. More like a shell where you protect what's inside that cloud from any external communication and traffic and disturbances. And the necessary things to scale things then is to be able to communicate also between these local clouds in a secure way. And this is also accommodated by some support core systems. That means that we can scale this more or less to infinite size of involved entities, only provided that we can manage all that in a way that we can understand what's going on. But that's another question. So this is also going to be touched on some of the discussions later on, and this is connected to, I think, what we will hear from Gabor Singler later on, how this has been utilized in their business example. Next is interoperability. Arrowhead already provides translation mechanisms for translating between popular protocols like HTTP, CoAP, MQTT, WebSockets. There is also a support for a number of legacy protocols with adapters like OpenCUA, Modbus, Z-Wave, Zigbee, IO-Link, and so on. And there is still early, but there already is support libraries for adapting to specific data models like the ISO 10303 and the STEP 242 data models, which I think is super important for the future of integrating our production industry, our service industry in a more efficient way than we can do today. So how do we engineer solutions using this? Since we have then taken the microservice approach also to the domain of engineering solutions. And we have looked at a well-known engineering standard, particularly used by the process industry, production industry, IEC 81346. We have added some extensions to look into the evolutionary capabilities of this standard, and then started to apply the microservice approach to this. We have then integrated this with system modeling using SysML. And this slide is just to show that the engineering process now is on the x-axis, and the solution, the architecture, the Eclipse Arrowhead architecture fundamentals are on the y-axis. And the numbers you see here is just a way of how you can choose to actually create your individual engineering process for the specific use case example. There is a full webinar on telling these things in more details, but that's not the story for today. So where are we right now? We are with version 4.4.1 of Eclipse Arrowhead, which consists of quite a number of what we call mandatory core systems. That's the ones at the lower bottom here. And then a number of what we call core support systems. I've here put together all the ones which are released in the version 4.4.1 and the ones which are expected to be released in the 4.5 release coming later on this year. So it starts to be a comprehensive set of technology which can help people putting together solutions of various kinds. We are currently also working on the specifications for the version 5 of Eclipse Arrowhead, and it's quite a comprehensive work with, I would say, a large number of players, both from academia, where things maybe started, but also very much from a number of the industrial players that we see here today in this webinar. So where are we with validation verification in industrial production? Within the Arrowhead Tools project, which currently is one big supporter of Eclipse Arrowhead, we've looked at more than 10, there is maybe more than 20 now, but the numbers I've collected so far is from more than 10 of the industrial use cases, relevant use cases. And in the project, we had an objective of saving 20 to 50% of the engineering cost for creating solutions. The actual results points to something between 30 to 95% of cost reduction compared to current industrial state of the art. Significant numbers, and since we do have this from a number of type of industries and also along the complete line of the engineering process, I think there is some significance in these numbers which should not be ignored. So something good is there. What about competitors and other technologies? We did some comparisons. This is about 1.5 years ago, so it's reasonably up to date, where we compared Arrowhead with BASIC's Fireware, IoTivity, Lightweight M2M, OCF, etc. And it's quite interesting to see that there are very few that actually supports real-time. Arrowhead is one of them. Very few that actually supports a wider set of communication protocols. And here Arrowhead shines out quite a bit. And we also know that there has been provided interoperability with Fireware and BASICs. So we can build together with these guys. And it's interesting to see that we have a lively continuous development. So if we take just the communication protocols here, with all these adapters that's now showing up for the 4.5 release, we will have quite a comprehensive interoperability out of the box of Eclipse Arrowhead. So what about resources to learn more? I would first like to point to the YouTube channel, where there is quite a good set of videos from very basic things to how-tos, how to actually hack the keyboard to get you into things. There is web resources. The web is currently is under update, so we hope to see a new web in a couple of weeks' time. All the code is located at GitHub. All release code is located there. And then there is also a book if you want to learn a little bit more about the theory behind. But in conclusion, and as Gail pointed out, Industry 4.0 is kind of the target from where the requirements has been taken. And we claim that it's clearly possible to build both a legacy ISA 95 architecture for any production automation, or building on the newer architectures like RAMI 4.0. And it's also very clear that engineering efficiency seems to be in a league on its own compared to how we do it today. And open source, and with all the support of Eclipse, we hope that we can provide a stable and legally nice open source code to the community. And it's also very clear that it's in commercial use by several companies already, and you will hear some of examples of this in the coming talks. So this ends my presentation on Eclipse Arrowhead. Thanks for listening.
Thank you very much, Jerker. Let's see as well. Concerning the length of the talks, I made a little mistake. It's not totally 15 minutes for everybody of the 6 that are coming now, but something between 10 and 15. So we'll try to be a little flexible. Next one coming is Kjell Bengtsson. He is Vice President at Jutne, which is a software company specializing on data interoperability solutions using ISO 10303, which you heard about already. So he has background, among others, from Volvo and General Electrics, and he will talk about the domain of ASD, Aeronautics, Space and Defense.
Hello, Javad. You need to make me presenter, thank you. If you can hear me. I can't share the presentation, so go ahead.
Now you should have the possibility.
So try if you can follow up the other persons when I have 10 minutes only, okay? So that's fine, thank you. So before starting, thank you very much, Jerker, about the introduction to the Arrowhead framework. I take the opportunity, if you're interested to see Jerker, he will be in Brussels, I think May 2 to 4. And together with a lot of other people from Arrowhead anyway. So if you happen to be in Brussels that week, I'm sure that both Jerker and other team members from Arrowhead is interesting to see you at this brokerage event for the KDT. So thank you. This presentation is from our company, and it's related to aeronautics, space and defense. Jerker talked about interoperability. Our company have been in interoperability for more than 30 years, and we will tell you how we have connected the Arrowhead framework, the IoT framework, into other industry standards. So we have our legacy coming out from something called ISO TC 184, subcommittee number 4, which is related to industrial data. So if you happen to have interest in these kind of standards, more specifically, this presentation will be about ISO 10303, which is about managing 3D CAD, PLM, logistics data, simulation data, and so forth. So by that, I take the first slide here. And what you should look into this specific slide is to the logo type in the upper right-hand corner, where you see industry associations like AIA, which stands for Aerospace Industry Association. The equivalent that we have in Europe is called ASD, Aeronautics, Space and Defense, which is the equivalent membership organization. And our company have been working with this, I would say, playground for many, many years. And some time ago, they issued a quite interesting position paper called the Digital Twin Definition and Values. And our company obviously work in that business, and we adhere to that kind of statement. What you will find in that position paper is that they have concerns about digital twin across the life cycle and the supply chain, meaning that an aircraft or a car, whatever, have many digital twins from many subcontractors, and we need to retain them over the life cycle. So very important aspect. They also issue the requirement of using open standards, data and models, and also have a life cycle architecture frameworks in place for achieving these objectives. Further in that same document, you will see 17 digital twin application and value examples. So it's a good reading about how to create a digital twin in the supply chain and also over the life cycle. And what we have been doing with the Arrowhead framework now, we have had it in operation for 3 years. And what we have learned is that we can actually create digital twin in days, not in months. And the major, I would say, capability that we add to this is that we're able to attach standards into this implementation. And we have somewhat of a 3-click scenario in place now. You can upload your step files into a repository. You can mount your sensors into your systems, and it's very easily then to connect the data acquisition part into the Arrowhead framework, and you are done. And that also means that we can store the data very efficiently, but also that we can do the correlation between the simulated data and also the actual data coming out from the digital twin in operation. So we have many examples of that, and where we have connected, like you see on the graphics here, the glider aircraft. We produced a winglet connected to the test scenario. We have done it for manufacturing systems and also in operations. We have demonstrated also for the European Space Agency and many of our customers. In addition, what we think these kind of standards can be very helpful for is that we have now a lot of smart people doing AI and machine learning application. And we need to find a foundation to better support these smart people, right? If you have a smart PhD student coming out of the university, they will then try to do some smart with your data, just to discover that they do not understand the context of the data and spending a lot of time to cleaning the data. So that is something we think that these open information models can help you with. The other point is that we have all these sensors, and about 80% of the professionals think that interoperability is the big challenge for this. So what we think is that you need to address this by connecting reference data libraries for sensors, meaning the output that they can give and also what kind of standards they can provide to you. And I think the combination of our ISO standards and the Arrowhead framework will help people to connect their system much more efficiently. Another point is that this is somewhat the legacy of the ISO 10233 standard. Most people still think that the STEP standards is about 3D models only. That couldn't be more wrong. The ISO 10233 standards not only could connect 3D models, they connect PLM systems, they connect logistic support systems, and they also connect simulation data management systems. So this is the history of the development of the STEP standard, and people need to start thinking how to integrate not only 3D CAD models, but also PLM system, integrated logistic support systems, and more specifically the finite element systems like Nastran, Abacus, and other tools that you need to connect. And doing so, we think that this kind of technology stack can help you to improve these data exchange and sharing processes by utilizing open and international standards. One example is that we have been running in the Arrowhead project, and these have been in operations now for 3 years, where we're able then to connect the sensors. The sensors goes to a gateway that could go to the cloud, or it could be installed locally on at the crane. What we have been doing here is that we have been utilizing all these components, and of course Arrowhead, and we have connected through a standardized REST services API, and that goes directly into the ISO 10333 repository. What you actually see on the screen here is that you have sensors values coming from the crane. It's go directly into a finite element solver that actually running faster than the actual crane. And that can help us to look into the condition-based monitoring aspect of the crane. And we can have these simulations having impact from the sensors values, and it can run 24/7. So if we have a new type of value coming into the crane, we can then put it into the finite element solver, and we can recreate the simulation. We can see what kind of impact that will have on the crane, meaning that we can reduce maybe time for maintenance. We are better planning ahead for what kind of maintenance that we're looking for and so forth. The good thing is that when this data is stored in this repository, It can then be fed back to CAD system, PLM systems, or other simulation packages, or your in-house tools for doing correlation and validation of your data. So this is a very good example. Just to give you some details about this, we're measuring data every second from the crane. I've been doing so for the last 3 years. So we have collected a lot of data in this installation. And so we have discovered very few problems. Arrowhead is very stable. And we have actually done 2 upgrades for the last 2 years, I think. And we have had no problems to collect the data from the sensor through the gateways and so forth. Optionally, you see also a Grafana dashboard there, where we can present the data not only in a map, but also all the individual sensors. We have about 15 sensors and its related data points, then submitting data every second. And we do that using 2 gateways. You see the gateways there. One is for the mobile communication, the other one is using the internet available on board. So we can actually then submit the data through both telecommunication and through internet stored locally on the ship. The PLC gateway you see there, it's an ABB gateway that is normally supplied from the crane manufacturing, being Palfinger. But you also see a small box to the left there, which is the Pluto gateway, which allows us then to connect the sensor values directly into internet. We also have added other sensors that goes directly to the gateway used for telephone communication there as well. So to sum up, what this might be good for the aeronautics and space industry is that we think that these standards coming out from ISO 10333 can support this stack of requirements. When you're supposed to develop a new product, you need to execute these steps here. You need to ensure that you have your requirements in place. You need to track changes. Obviously, you need to develop your architecture for hardware and software. You get your product into manufacturing, testing, and quality. You get the operational data. And at the end, you also need to hand over a technical data package to your customers. And to the left, you see one example of that. You see a winglet being produced, simulated. It has been manufactured, and it's also creating a lot of sensor data for testing and in operation. So by putting all these pieces together with Arrowhead, we think you can break up the silos of information that you have in your companies, especially also for new products. And we think that this enables the interoperability to support the digital twin and also the digital thread. So Jochen, I think this is about my 10 minutes. So thank you.
Well done, yes.
Thank you.
Indeed. Welcome. Thank you. Very good presentation. So from here we move on to Maurizio Griva, who is with Concept Reply, specialist in industrial IoT. And Maurizio is an IT professional, has led many implementation projects and has Six Sigma background. And he will introduce us to the domain of smart city and mobility and the use of Arrowhead there. Welcome.
Thank you. Good morning, everybody, and pleasure to be here. Is possible for you to push the slides on my behalf so I can just comment them?
Do we have them here?
We have them here.
Right. We do.
Okay, thank you.
So it's not sharing yet. I need to do something more there.
Okay. So you need to do my presenter again, Javad. I think you stop me being the presenter, Javad. Can you make me presenter?
Yes, Dan, I made him already. Now you are the presenter.
Yeah, the rest of the present slides will be run from this PC, so you don't need to change anymore, okay?
Oh, okay, great. You should change your presentation view. Now we see the presenter view. Exactly.
Coming up. Here we are.
Yeah, great.
All right.
Thank you very much.
Welcome.
Yes, you hear me?
Yes, we do.
Okay. So our case of Arrowhead is a case that is about the application of a smart city platform. Now we'll discuss a little bit with more details with the Arrowhead Tools platform, and in particular getting the benefits from the usage, the extensive usage of the Arrowhead Tools schemas and tools for solving the problem of the very fragmented silos and sensors that and applications that rely on a typical smart city and smart spaces implementation on platforms. So next slide, please. So basically, the core of the issue is to really speed up the integration between the legacy engineering and IoT system of systems. In particular, the focus is to extend the hidden interoperability that is built in these legacy systems with the newly developed standards in the last years, including COAP and MQTT for the message, as well as other standards with existing systems. So why we care about legacy old systems? Because even they are silos, so basically designed with having only a vertical application in mind, and namely in the smart cities, we have the traffic light management, the ticketing for the smart parking or the parking systems, the management of the emergency vehicles like ambulances, the verticals for monitoring the quality of the air and the level of pollutions, as well as many others. Those systems cannot be just redesigned and re-implemented because they contain a lot of historical data. They are interfaced with a lot of long time installed sensors and communalities like this. So having a migration path which can benefit from the new technologies and at the same time maintain the operability and the functionality of those systems is paramount for smart cities. Only few cities have embraced the full greenfield or brownfield, let's say, re-implementation of all the systems, creating what was called the city manager dashboard, because it's a very large effort. It requires a lot of money and focalizations of the entire community of developers and systems of the smart city into one single project, which never happens for all these things. So having a progressive approach, and here the Arrowhead Tools platform is really helpful, having a progressive and iterative approach into adding new systems and services and sensors to the existing and legacy implementations is really a key parameter for evolving the platform. So the impact that was expected and carefully designed by us and our partners on the system of systems is to have an easier integration and more effective interoperability framework. So the flexibility that we expect is high level of reuse of software components that are developed during the years and integrated in the smart city platform, which is built on top of the Arrowhead Tools platform itself. Next slide, please. So the problem that we found in these smart cities implementations can be resumed with this graph on the left, where we have basically, due to the fact that we have lack of IoT interoperability and a lot of vendor lock-in problems, so systems that have been developed by a specific vendor with proprietary interfaces. This hampers the scalability. So each time we want to increase the population of sensors, we face increased costs because it adds up to the maintenance cost and new technology. The technology becomes unstable and not stable because it's poorly managed by the city councils through expensive contracts. And there is little of authority on the network. So network is made by a network of networks and is prone to malicious attacks as well as to simply degradation of performances in networks that brings down the connectivity and the quantity of high valuable data that could come from gates, cameras, and other sensors which are distributed. So the key drivers of the solutions of the implementation through the Arrowhead tools is to exploit from now on open and public available international standards at each level. So from the data connectivity to the networks to the interfaces and data standardization. Use software-driven technology. So each time a proprietary implementation, even at the electronic board level, can be substituted by a microprocessor running open source, in particular open operating systems and MCUs as well. It's beneficial, and each time we move from a hardware-oriented to a software-driven, it's a positive step, even if requires a proper attention for cybersecurity and maintainability standards. And of course, as we already talked, having open service interfaces that have been applied from all the systems. Next slide, please. So the platform that we have developed together with other partners is called Vital IoT, comes from a previous European project and has been evolved into a complete client server smart city management application and platform. The Arrowhead tools has been used for interfacing the plethora of existing legacy and newly built sensors and gateways into the platform, getting all the benefits that I explained in the previous slides. So new components like Edge AI, so algorithms like neural networks that could be executed on the edge, so close where the data are generated, taking into constraint the fact that we have little executing capabilities in CPUs, we don't have GPUs, and we would like to exploit as much as possible executions on the edge. It's new and it's been capable to be integrated with the Arrowhead platform. The IoT framework has been applied with the paradigm of connectivity by IoT, by Arrowhead tools, standard REST APIs and other kind of interactions tools that speed up through the tool chain the selection, onboarding, configuration, maintenance, and end of life of the distributed sensors, which are peculiar for the smart cities because there are a lot of computing bodies from traffic lights to sensors of quality, air quality distributed and let's say left in the wild. So having a methodology for updating remotely the software and getting health status and possibly maintaining them remotely is extremely important for reducing the maintenance costs of such components. And from the deployment, we want to have zero downtime. So each reconfiguration and deployment should be done while the computing is executed, and we don't lose any data. So we have a particular firmware over-the-air update system that runs in parallel to the data collection from Arrowhead tools. Next slide, please. So just summarizing the benefits that we collected in a reference smart city, the major drivers are the reconfigurability at runtime of the census edge and gateways, having a true distributed architecture that can be designed and managed and expanded, completely known from the center to the smallest of the leaf, and not being prone to interfaces and connections between vendor locked, partially open and partially closed architectures. This exploits the design of security from the beginning, because we know perfectly how they feel how they fit in the architecture. This impacts in reducing the development time for software and reducing the lack of interoperability. So coming to a figure, we can state that Arrowhead helped to reduce by more than 90% the onboarding, activation, software deployment, software operation, monitoring, and maintenance activities during the entire cycle time, or the complexity, reducing the complexity of doing such processes through a reference model that we applied using a model-driven methodology, and with the new data providers that we exploit in Vital IoT. So I believe this was the last slide, so I hand over to my colleagues again.
Yeah, thank you so much.
Welcome.
Not one in time. So let's see, video here. Yes, the next colleague is Frederick Blomstedt from Cinetic, and we have it here. So they are experts in data communication, service-oriented architectures and real-time systems, and implementing solutions for government and industry. And here the topic is an Industry 4.0, as it says. So welcome, Frederick.
Yeah, thank you very much. Hi, everyone. Can you hear me?
Yes, we do.
Yeah, great. So the background is actually to replace the MES system in a truck manufacturer company. They had an old 20-year-old MES system that was going to be exchanged, and the requirement was to do it in runtime if possible. So we started to apply the Arrowhead framework and see, after the project was done, it has been in production since 2019, so it has been in production for 3 years. We can see that we actually achieved controlled flexibility, mean to handle the change and demands from the business, both IT demands, but even business high value demands. So we can change the solution depending on different demands on the shop floor or from the business. So it shows that, okay, due to all those future requirements that always change from day to day, we can meet them by using Arrowhead framework. And the first one is actually to follow the Arrowhead framework architecture, really hard discipline to know, okay, this will be the governance. We will handle definitions in a common way. We know what we mention when we say MES system, when we talk about SCADA systems, when we say interfaces, services, and so on. And we will also align the architecture and the mindset from the management, and even from top down, from the developers and the technical people. One of the focus area is to achieve interoperability. So it's really high focus in service type, handle the APIs, how to manage the APIs and govern the APIs. So one of the core systems that we see is the most critical is the service registry. And then to follow the Arrowhead framework, the architecture, of course, those characteristics regarding service-oriented are the ones that need to be followed. And we see when we follow those 3 L's, we actually achieve this controlled flexibility. So those 3 areas has been the most important and helped us during the project. Next slide, please. So the challenges and some of the pains, it's always how to do this and how to align business and also developers. One of the critical issues is to have this distributed mod. You don't know how to handle all of those interfaces, how to handle all of those technologies. How can we share them between our teams and within the organization? So it's often get really messy and the knowledge is on each personal level. So we actually needed to take care of those issues and put up goals for the project. And one of those goals was, of course, to handle collaboration, how to do maintenance. Even if we have distributed system, it should be easier to do maintenance for the IT operations, as example. We should actually be able to replace the heart while running, replace the old MES system with the new one during runtime. And of course, that's the challenge itself. Then we need to align, have this common mindset, how to do integrations in a common way, so we can share and reuse integrations and reuse APIs and interfaces. A lot of questions regarding who should be the owner of the system that we build. If we build directly update legacy system, of course, there might be already some managers that are responsible for that system. But if we build adapters, who should own those adapters and where should they be deployed? And if we have 20 or 30 different adapters, how to maintain and govern them? Also handle all of those dependencies questions, vendor lock-in or technology lock-in or some old legacy system that control how the future should look like and handle so we are independent of those regarding the changes. So those were the pains and the challenges that we needed to take care of. And then we go to solution. Next slide, please. So actually, the MES system, it was to produce side members for this truck company. And you can see in the left square, you have a system of system description. So all of those squares are actually their own system, and you can see the interaction points, those really small and tiny lollipops and forks, those are interfaces or services. And at the top level, we see the ERP system that are pink, and you can also see some of those white that are central service register and so on. This green area is the complete MES system components, and all of those are separated in several servers. And they interact with each other and control this blue area that are the SCADA layer. So from this picture, we can actually convert this old ISA 95 layer to a complete Arrowhead cloud. And all of those possibilities regarding the lollipops and forks, we can exchange information between the system that's provide or consumes the corresponding interface. So we can use a component where we see we have a need for it. You can see this service-oriented architecture, cornerstones. Those are cornerstones that we saw within the project. Those are needed to be able to handle the project and to share the knowledge within the organization. So it was, of course, this discipline that we mentioned, and it was to have integration and services in focus. So next slide, please. Yeah, what we see was the value from this project was actually directly in production. We can see, okay, we increase production. So from 600 side members in daily produce, we went up to 60 side members. So the first 2 weeks, we actually had 3 daily records. So it was really, really nice. And we saw also that we seamlessly could replace this old MES system with a new one by running them in parallel and disconnect it when we saw, okay, it's the new heart is actually working. So it was really, really nice production days. We can also see that if we have integrations in focus, we can actually change for new demands and new requirements. We saw that, okay, we need a new measurement system that should be connected to the new MES system. And we could actually build this new system in just 2 weeks' time and deploy it directly in production and seamlessly connect to this new measurement system, just running in ordinary daily basis. And we can see that using the Arrowhead framework also supports the complete organization with the future digital transformation. So by applying this concept, we could actually apply it on all of our production units, not only side member, but even rear axle housing and so on. So it solves a lot of problems and shows really high value to be able to follow the Arrowhead framework. So yeah, that's presentation from my side. Thank you very much.
Thank you, Fredrik. So we move immediately further on. And then, yeah, this is when he says to Gabor Singler, who's working for EvoPro. And Gabor leads Industrial Software Solution Business Unit over there. And he has experience also from other companies, from Siemens, among others. And has led large software development programs. So he will tell us more about the Internet of Things and Arrowhead. Welcome, Gabor. If you are there.
Yeah, now, can you hear me?
Yeah. Yes, now we hear you.
Great, great. Okay. So I'm really pleased to see so many webinar attendees here. So this was mentioned, I am Gabor Singler from the EvoPro Innovation Labs from Hungary, and I am the leader of the Industrial Software Solution Business Unit. We've been involved in the former Arrowhead projects like Arrowhead, the initial project of Arrowhead development, the Productive 4.0 and the Arrowhead tools. And our main focus is on the legacy system integration. And mainly I would talk a little bit about the IoT and the industrial IoT vertical domain and our business case, which is shortly introduced, is about applying Arrowhead in an electromobility ecosystem, where the main target was to improve the user experience and the support the smart grid energy management. So thank you for stepping aside. So everybody knows and heard about IoT, I think, but mainly, of course, the Internet of Things is about to connect physical objects into a network, and these objects contains embedded technology and embedded solutions in terms of software, and they have to communicate and sense or interact with their internal states and or the external environment. And these objects, devices, of course, can range from the everyday objects to an industrial tools, and using smart connected objects give you the possibility not only to send or sell products, but user experiences. For example, with your watches, you of course you sell watches as a product, but using its functions, the product tracking the usage of the product, you can sell wholesale services. And the IoT, the major technologies that empowers IoT, of course, the 5G, the artificial intelligence, and the big data. And there are a lot of pictures you can find on the internet that what are the projected numbers of the connected devices. I won't talk about them. Just a short, some sentences about industrial IoT as IoT. As IoT is a consumer-centric concept, whereas IoT is more focused, of course, on the supply chains, the manufacturing, and the management. And the key factors for the IoT is the cost reduction to make much more efficient inventory management and make the operations more agile and reduce operational cost. But probably the biggest factor to use IoT is the mass customization, and the mass customization requires an increase in various products and tools, which results in diverse in inventory. And of course, it has an effect on the production itself, because we have projects where we work together with car producer companies, where the production itself is very diverse due to these demands, and you have to solve these challenges. And of course, if you can achieve the faster and efficient manufacturing, then the other factor can be achieved as well, the shorter time to market. And if we can go to the next slide, please. The challenges of the IoT and the platforms, towards the platforms, of course. The main challenge is to ensure interoperability among the systems you want to make interoperable. And this is the challenge because, of course, you have systems with diversified communication, different ways of data representation, and the different security solutions which you have to harmonize. There could be hard real-time responses, and the runtime reconfiguration is a strong demand as well, to be able to reconfigure dynamically your systems in runtime. And as it was mentioned by Jarkko formerly, there are a lot of public cloud solutions out there from Amazon, Azure, Google, and ThingWorks, but there are IoT platforms as well. These are more specific platforms like Autosar, Biasis, and the Fiverr. So yeah, it's quite hard to choose the best suite for you. For example, because Arrowhead provides the former mentioned local cloud solution, that can be a very good point to the Arrowhead, because we know Hungarian railway companies who don't want to move their data, for example, to the public cloud, because they don't trust in the public cloud services and security. In this case, you have to solve these challenges using an IoT platform which is flexible enough to do this. So how to choose best platform? If you can, my advice is to start somewhere in the beginning of the alphabetical order, so you will find Arrowhead there. But yeah, of course, I'm just kidding. So we can move to the next slide. So the presented small electromobility business case, we used Arrowhead here because the most important characteristics suits to this business case. It was mentioned the architecture itself, because the Arrowhead is a distributed service-oriented architecture. and it provides a local cloud concept. You don't have to move everything into the public cloud if you don't want to, and provides core services for the core functions, and it ensures the runtime reconfigurability using the orchestration core system and the orchestration services, and even a secure onboarding where you can onboard different systems to a local cloud dynamically and in a secure way. And it provides a security by design with its authorization authentication core system. And since it's quite lightweight, the overhead of integration legacy system into the Arrowhead cloud is quite manageable. So that's why we used here. So the business case itself is about a small electromobility ecosystem where you can see there is an electric charger as an EVSE, so an electric vehicle supply equipment. Which is for charging electric vehicles, of course. There are virtual batteries in the system, and the target of the purpose of these virtual batteries is to store battery-specific data collected during the charging processes and store data from outer sources, for example, from a battery producer. And these batteries can provide data for the charging manager to improve the charging process of the individual batteries, for example, to optimize the battery's lifetime. And the charging manager itself is a generic, we can say, charging manager actor, which is an OCPP compatible charging manager server, which is a standard application level protocol in the electromobility ecosystem. And it acts for accepting user requests for charging, and it discovers the services for the user. And here I would like to highlight that the user, it discovers services. So the user really don't want to usually look for a specific plug or a specific charging station or a specific object or device. He looks for services because he wants services. And the charging manager itself can even cooperate with an external system which can be placed in a different cloud. So it can make an inter-cloud communication as well, where the virtual energy market is present or a smart grid operator is present. And so the charging manager itself is capable to get a power consumption plan for the charging process, and from that it can create a charging profile based on the virtual battery data received from the virtual battery data and received from the smart grid operator, and this charging profile can be shared with the charging point itself, and the charging point itself is capable to execute this charging process based on this charging profile. This charging profile is an OCPP specific thing that can be executed by the electric vehicle supply equipment. And so if we can go to the next slide. You can see here the general benefits of Arrowhead using in IoT or industrial IoT, but what it helps, what helps the main advantage was in this business case that we were able to improve the user experiences, as it was mentioned before, for searching for services instead for specific objects or devices, or you don't want to have a list of chargers and selecting or make decision when you are driving. And it really helped to develop a dynamic and flexible ecosystem to support the smart grid functions to make the energy supply, the balance in the energy supply. And of course, it provides an easy integration of existing and newly developed systems as well, because the Arrowhead itself provides integration tools, code skeletons in Java, in C++, and even it's available in Rust as well. It will be published soon. And it provides a clear documentation concept that helps the development process itself. So, yeah, that was my presentation about the Arrowhead. Thank you very much for listening and enjoy the webinar.
Very good. Thank you so much, Gabor. So we are well in time. And next in line is Dr. Jens Eliasson from ThingWave. And he is the CEO of ThingWave. So ThingWave focuses on industrial IoT as well, and are caring for efficient energy efficient solutions for cities, mines, industry in general, and should thus have a good market these days. So, and as the title here says, it's energy in focus for Jens here. Welcome, Jens.
Thanks a lot. So I will be presenting our work in making especially mines more energy efficient. So can you take the next slide? Yeah. So we are working a lot with digitalization of the mining operations. One of the biggest drivers for energy use is ventilation for underground mines. In many cases, it can be somewhere between 30 to 40% of the total cost and up to 50% of energy just to run ventilation in many cases. So large savings are possible. Recent years, there's been a lot of development with ventilation on demand, which makes big impact. But of course, if we want to shave off even more percent, we need new solutions to be able to achieve that, especially when it comes to integrating data. So there are usually a lot of different systems running in a mine. They can have old legacy systems from the 80s and 90s still operating, working good, so there's no need to change them. Mines don't like to change things if they work. If we take the next slide. So what we can see is that there's a mixture of both new protocols, for example, OPC UA, typically powering the ABB control systems, which is running the entire ventilation. We can find very old Modbus devices, either running pure Modbus or Modbus TCP, for example, fan controllers and the temperature sensors and the ventilation sensors. On the other hand, we have modern IoT protocols, for example, MQTT, we always find HTTP. So we have this mixture of multiple technologies, some old, some new, some running full security, some running without security. So to be able to kind of come up with a solution, we need to support security interoperability, protocol interoperability, and semantic interoperability. Some of the older protocols, they basically don't have any semantics. They just run hard-coded binary data. So we need a way to make all of that work together. Next slide. So what we have been doing is leveraging the power of Eclipse Arrowhead, where we have multi-protocol support from start, which means we can run solutions where we inject data and fetch data, running basically any type of protocol. Our focus in ThingWave is more on sensing, and we leave the control and actuation to other companies. But when it comes to integrating old systems, that's where we see typically this really mixture of different solutions running all kinds of hardware and all kinds of protocol. Another issue that we have seen just the last couple of weeks, that is the issue of the IPR. So when we go in with our IoT platform and we need to make changes, which is quite common, we always come to the discussion, okay, who owns that IPR? If we make few small changes to our cloud platform, should the customer own that? Typically no, but it's always a discussion. So by distributing the solution into services and systems, we can actually create new solutions which runs completely standalone as a system. It interacts with our existing system using services, and the customer can own 100% of this new system because it's completely standalone. We don't need to touch anything in our backend since we run everything over services with well-defined protocols. And this also enables us to do really rapid development cycles since we don't need to touch our big IoT framework. We can just create new systems that handle big or small things. We have them up and running. We have the security, and we can just start deploying them in a very rapid way. So we can also move away from these long development cycles where we need to test everything all the time. So we can focus on just solving the issue. Next slide. So kind of to conclude, how we leverage Arrowhead is that we really need this multi-vendor, since nobody likes vendor lock-ins any longer. And we really need these multi-technology capabilities where we have mixed security protocols, mixed communication protocols, mixed semantics, mixed pretty much everything you can find. Ranging from really old things, both us or even older, to state-of-the-art things like OPC or MQTT or whatnot. And the power to segregate and to isolate development makes it quick to do the development. And by running runtime orchestration and also configuration, we can deploy the solution and configure them even from one central point. We don't need to have access to all the devices all the time, so we can configure them using Arrowhead in a centralized manner. And of course, this saves a lot of development time since we can reuse a lot of existing software. We don't need to focus on testing everything from start all the time. So we can really just put our attention on creating new things, but have them up and running very fast using standardized technologies. And always we have the security coming in from day one. So again, there's no need to reinvent anything. And of course, this allows us to save a lot of time, it saves a lot of costs, and it allows us to be very agile and work together with the customer to solve their requirements and needs without always getting stuck on long conversations on who owns IPR or how integration should be, and so on and so forth. So this was my presentation on how we're using Arrowhead within ThingWave, not only for energy, but this talk was focused on the energy part. So thanks a lot.
Thank you, Jens. Very interesting. So then we move on to the final presentation. This is by Dr. Javad Dobrani from University of Lübeck. And he's Javad is leading the Intelligent Systems Lab at the Computer Engineering faculty over there, and does research in distributed software systems and in microservice architectures, and at the same time also teaching various courses at the university, and was a member of the Arrowhead Tools project. And he will introduce us to semiconductor and consumer industry issues related to Arrowhead. Welcome, Javad.
Thank you. Hello, everyone, and welcome to my presentation. So I'm going to talk about the integration of Arrowhead framework as an automation framework into the consumer industry, and also customize it for every industrial system. So if you go to the next slide, you will see that nowadays we are actually using the automation in the production. So the systems are fully automated. The production systems consisting of different production cells connecting together, but we are moving also from the automation to the digitalization between the Industry 3.0 and the Industry 4.0. has been already started, this moving between these two technological changes. So in the digitalization and the production, we are talking about the mass customization and not the mass production that we had through the automation. And the systems are not only controlled by the computers, they are connected together and connected through cloud and edge systems, and it provides the interconnectivity and interoperability between systems. And the Arrowhead framework, as you have also seen from the beginning of this webinar, that the Arrowhead framework is one of the motivators and pioneers in this area to bring the interconnectivity and the interoperability between the systems. So a lot of benefits are there if you're going to digitalize your production system and migrate from the automation. For example, you will benefit from higher quality and reduce the prices, and also higher customer satisfaction because you customize the production for them with less prices and also more accuracy. And this will make your company also competitive against the other companies from west and east of the world that are also struggling to have. Can you please go to the next slide? So, benefiting from the digitalization is, so can you change the slide to the second one? So I'm still seeing my previous slide. Yeah. So benefiting from these advantages of digitalization. No, please go to next slide. That's slide number 3.
I think there's some latency in the network, right? So
okay. Yeah. In order to benefit from the Industry 4.0 and also the digitalization, you should usually change the structure of your systems, because we are going to interconnect and also to provide this connectivity and connection to the cloud, to the edge systems, and so on. But the point is that we have the automated systems. They are running very nice. They're running since 20, 30 years, and with low costs. So that is the trade-off. Also, that is the bottleneck of migrating to the digitalization in the production, because a lot of companies cannot change their running system because of a lot of dependencies that they have there. That is also reorganization and refactoring the system is also required for doing such migration. And that is the biggest problem and the biggest issue that prevents the companies to move forward to the digitalization, and therefore they are also they are leaving, they are just losing the competition, and they cannot keep the pace. But what is the solution? We are going to talk the solution, how to handle this situation. In the next slide, you will see that we require tools, and the Arrowhead framework is one of the best tools that you can count on it, and that you can invest on this because of this great community. You have tools. That is the basics, the base, and the most important framework for the interconnectivity is there. But you need also additional tools to analyze your system, to first of all create an architecture that is more flexible, and you also know how to be able to migrate your system from the automated into digitalized. That is actually what we have brought in the project as a partner, and we shared our know-how. The tool is there, and we are also ready to share our know-how gained from this project, and also our previous know-how and our knowledge and expertise about microservices architecture. And we are going to support you and your companies to do this migration. to be able to change your system architectures in that way that you can benefit the digitalization and also struggle less with the problems and issues there by this migration. So what is actually the flexible architecture? Why I'm talking all the time the flexible architecture? In the next slide, you'll see that almost every computer system, because of all dependencies, is in a form of a monolithic architecture that you see on the left side of the slide. These monolithic architectures have a lot of dependencies, and they are very solid architectures. You cannot change them. You cannot. They are not flexible. They are also not easily extendable, and they cannot also they cannot do some self-healing and resilience. But if you bring this microservices architecture and microservices philosophy into your monolithic architecture, you can change it into smaller systems as microservices and put the arrowhead in between them to handle the interoperability between them. And then your system will be really flexible and also extendable, and the key and also the power of the microservices is actually in this kind of flexibility. So in the next slide, you will see our success story that we have used this know-how, and also with Infineon as our partner in the we helped two bases of Infineon in Dresden, Germany, to migrate their data, their monitoring system and their sensoric system to the new flexible architecture of the microservices, and then integrate Arrowhead to their IT architecture. And after that, they could handle the changes in their system. It means installing new software, installing new sensors, and also changing this kind of data production and also consuming of this data for their machine learning and also monitoring purposes from 3 months to 1 day. We speed up the process of handling the changes in the IT architecture. We have changed the IT architecture, IT infrastructure, and IT architecture to the microservices-based architecture, and they could handle the changes that they used to spend 3 months to handle that in their fabric, just to 1 day. And that is the power of this flexibility. And it is also open for more other changes there. So in their previous version, in their monolithic architecture, changing something doesn't mean that you can change it further. But with the microservices architecture, you will be very flexible. That is the success story that we can prove that this kind of architectures using this know-how and tools work. And as the partner of the Arrowhead tools project, and so University of Lübeck and University of Applied Sciences in Dresden, we are also ready to support you and also to speed up your migration process to the digitalization. So thank you very much. So if you go to the next slide, that's my final slide, and you can start, the Q&A session. We have some questions. I give the word to the Shell.
Yeah.
Thank you very much.
Welcome. Yeah, thank you so much. So Shell is in this case me. So you had to leave early. But the question is, are there questions? Stephanie? I haven't seen any in the chat so far.
Yeah, we have in the Q&A session section 2 questions from Hassan Derhami.
Oh, very good. Yes.
And also Jose Luis asked about sharing the slides. We will share the slides presentations with you.
Right, exactly. Yeah. So there's a modern trend to analyze IoT frameworks from a control plan and data plane separation. Has there been any technical work around defining Arrowhead interims of control and data planes?
And Jerker here, I think that this question I can comment on, but there is no real concrete work on defining Arrowhead in these terms for the moment. Good suggestion, and you could add it to the roadmap.
All right. Thank you. And the second question, Hassan. Automotive industry IoT is preparing for a much more integrated and open data future with new regulations coming from centralized organizations. Have ever been active in some way with municipalities or others in terms of the integration challenges there? Yeah,
in general, the answer is yes. I just share my video as well. In general, the question is yes. There are players around whole Europe now involved for all kind of levels. And just as an example, in Romania, there is a concrete dialogue between a number of software companies and the implementation of smart city situations. And I don't remember the name of the city, but there are concrete things where this is ongoing. And we haven't seen the kind of conclusion of all these dialogues yet, but yes, there are situations where Arrowhead is in concretely on the table in dialogues between suppliers, implementers, and also the society organizations like municipalities.
Yeah, thank you. Maybe as a follow-up question from my side. You said we know in a way we have a version 4.4.1 of the Arrowhead framework, and you mentioned a kind of a release number 5. Where are we in the release cycle? Is the 4.1 a well validated and officially released version that just people can take and use?
Yeah, the 4.4.1 was actually released in January, end of January. And that was an update from the 4.4.0, which came in sometimes during the fall. I don't remember the date right now. And the 4.4.1 was just due to the log4j bug that was discovered in early December. And with help of a lot of friends out there, we could then update, in particular, some of the Java libraries and create a release in, I think it was in mid-January.
Yeah.
And then 4.5 is scheduled for, if things goes well, before summer or June, something like that. And the version 5, we are still working with the specifications for what's going to happen there. But there is a very concrete and very engaged industrial community. And we can see, for example, that the company Cinetic is taking the lead for some of these definitions. And just as an example, there are other companies involved as well. But it's cool to see, as an old academic professor, that industry is taking very seriously taking up the way of pointing where the future is with this technology.
Yeah, exactly. And when companies have additional requirements, as we heard just right now here, this question number 1, where would those be logged in a way? Should they go to the Eclipse framework, and then is there a way to write down some requirements?
The absolute easiest way is to go to GitHub and the Eclipse Arrowhead repository there, and there you will find a directory named roadmap. And if you have, then can recognize there is a click bottom named issues. and you click on that one, then you can see all the issues that has been submitted to the roadmap discussion. And anyone is free to submit a suggestion for updates, changes, additions. So it's totally free, totally open to suggest that. And then these suggestions will be taken care of by the roadmap working group, which are meeting at least monthly. Normally it's a 3-week schedule. And where we are looking into these things, and hopefully then people who are monitoring this will also react to your suggestions, and that we can then form a dialogue directly on GitHub, and then decisions, the first level of decisions will be made in the roadmap working group on how to address this and eventually when to address it as well. And if those decisions are taken or considerations are taken, then this will also show up as kind of tags to that issue.
Yeah. Thank you. Any other questions? Floor is open. Hearing none. So yes, as a little wrap up. So first of all, thank you very much to all the presenters. It was very interesting and to me also educational. So it's quite good to have then these presentations now also recorded. And the presentations we will obviously, and as I mentioned earlier, we'll send around. Yeah, then also thanks everybody for listening. And yeah, there are channels to communicate with the team. So use them in case you get issues or questions later on. Thank you, everybody. I think we closed the session a little ahead of time. Have a nice evening when you're in the European time zone. Otherwise, a nice day in Canada. Bye-bye.